Hello, we'll be doing the last section of the first chapter of chemistry, that is the language of chemistry. Here, first you have to know what is relative atomic mass or atomic weight. We all know that atoms are very small. We cannot see or take the weights of these atoms directly. So, there are certain indirect methods are adopted to know the absolute mass. So by different indirect methods, it has been found that mass of hydrogen atoms is 1.66 into 10 to the power minus 24 gram, and that of the carbon atoms is 1.9926 into 10 to the power minus 23 gram. But these masses are very small, so we cannot use kg or gram as the unit. So appropriate atom is considered as standard atoms as unit, and then relate the masses of other atoms. These resulting masses of atoms are thus called relative atomic mass, RAM, or atomic weight. You better use the term atomic weight always. Now here, carbon 12, that is the isotope of carbon having the mass 12, was finally selected as a standard. So the relative atomic mass or atomic weight is given as mass of one atom of element divided by 1/12 of the mass of one carbon atom. That is, the relative atomic mass or atomic weight of an element is the number of times one atom of the element is heavier than 1/12 times of the mass of an atom of carbon 12. Now carbon 12 is the isotope that you should remember always. So, the mass of an atom of carbon 12 isotope was given as the atomic mass of 12 units or 12 AMU or simply 12U. Generally, U in ICSE syllabus we use AMU. In CBSE syllabus generally U is used. So you should use the term AMU or atomic mass unit. So the mass of hydrogen is 1 AMU, and for oxygen it is 16 AMU, and for helium it is 4 AMU. Let's say for sodium, if you want, that is 23 AMU. Experimentally it is found that one atom of carbon 12 atoms has a mass of 1.9926 into 10 to the power minus 23 gram. The details of this can be shown or can be done by you in class 10 chapter 5. Now if you divide this mass by 12, AMU is obtained. So remember the value of 1 AMU or 1 U as 1.6605 into 10 to the power minus 24 gram. You have to remember this. Now come to the relative molecular mass or molecular weight. What is this? This is the number that represents how many times one molecule of the substance is heavier than the 1/12 of the mass of an atom of carbon. Very simple. In case of relative atomic mass or atomic weight, you have taken the weight of the element or the mass of the element, and you have checked how much it is heavier than 1/12 times of the mass of an atom. Now this relation you have to remember what I have shown in case of relative atomic mass. Now for relative molecular mass or molecular weight, it will be written as mass of 1 molecule of a substance divided by 1/12 of the mass of 1 carbon 12 atom. So in the previous equation, if you want to write this way, you will write mass of 1 molecule of the substance divided by 1/12 the mass of 1 carbon atom. So for the molecular weight, you will write the same way, only in the numerator it will be mass of 1 molecule of the substance. Understood? So the relative molecular mass or molecular weight is obtained by adding together the relative atomic masses or atomic weights of all the various atoms present in the molecule. It is the simple way you do find the molecular weight of different elements. Now let's say for H2SO4, you have 2 atoms of hydrogen, so it is 1 into 2, so 2 AMU. 1 atom of sulfur you have, so it is 32 AMU. 4 atoms of oxygen, so it is 16 into 4, so 16 AMU, 64 AMU, sorry. So the mass you are getting 2 into 1 plus 32 plus 16 into 4, so it is coming at 19 AMU. So the molecular mass of the substance is the sum of the atomic masses of the constituent atoms present in one molecule of the substance. So you can say this as molecular mass, you can say this as relative molecular mass or molecular weight. Similarly for atomic mass, relative atomic mass or atomic weight. But generally either molecular mass or molecular weight, and here atomic mass or atomic weight. These terms are used. Now see here this example. Calculate the relative molecular masses or molecular weights. So here A and C are very common. Now for B I will tell you. Here this is not the multiplication sign, the dot. Don't mislead by this. This is not multiplication sign, this is the dot. This is used as plus. So first you have to find out the CuSO4, molecular weight of CuSO4 plus 5 into water. 1 molecule of water is 18. So 5 into 18. So here it is done already. So this is generally done this type of mistake is generally done by the students. I guess it is done. Now percentage composition. What is that? Percentage composition is the percentage by weight of each element present in the compound. Now percentage of each element, how do you find? Total weight of the element in one molecule divided by the gram molecular weight of the compound. Now what is this gram molecular weight? Gram molecular weight is the molecular weight expressed in gram. Like here you want to find out how much nitrogen is present or percentage composition of nitrogen. Now here it is coming as 132 AMU for the total, that is ammonium sulfate molecular weight is 132 AMU. If you want to find out the nitrogen percentage, so here the numerator will be N into 2, that means 14 into 2 divided by 132 gram. 14 into 2, that is 28 gram divided by 132 gram into 100. So the total percentage should come as 100. Like if you take out percentage of nitrogen, percentage of hydrogen, percentage of sulfur, percentage of oxygen, it all together it will come as 100. Now take an example like calculate percentage of hydrogen in water. Now here these relative masses are given. There may be some occasions that these relative masses are not given. So you have to remember the relative atomic masses of some general molecule like hydrogen, oxygen, carbon, nitrogen, sulfur, chlorine, sodium. So all this. So if you practice, if you do the practice, you will automatically remember. For that you don't have to sit and learn the numbers. So now first find out the relative molecular mass of water, that is coming as 18. Now convert this molecular weight into gram molecular weight, that is it is coming as 18 gram. It is same, only use the gram after it instead of AMU. Now 18 gram of water contains 2 gram. Now here I would like to say, here sometimes you can say why AMU is not written. If you don't write over AMU, then also it is correct. Only for gram molecular weight you have to write it in the gram, because you cannot do otherwise. So 18 gram of water contains 2 gram of hydrogen, that you get it from here, 2 into 1. So how much it is contained in 100 gram. So similarly you can find out for oxygen. It will be coming as 18 gram of water contains 16 gram of oxygen. So 100 gram contains 16 by 18 into 100. Or from here also you can find out hydrogen content is 11.1%. So oxygen content is 100 minus 11.1. Now here you see this is a bigger one molecule. This is urea. This comes as I guess 60. Now 60. So you can make it this tabular form, which is easier for you. If you don't want, you can write it down. So find out this is, now nitrogen they have asked. Nitrogen is 2 atoms of nitrogen. One is here, another is here. So don't miss this. So 28 by 60 into 100. So it is 46.67. So similarly, if you find out the others, you will find the all over it is coming as 100. Then do example this one. Calculate the presence of various elements in Na2CO3. Here you have to find out for sodium, you have to find out for carbon, you have to find out for oxygen. So it's very easy. Now this one I wanted to do. This is find the percentage mass of water in washing soda crystal. This. So Na2CO3 dot 10H2. So first you have to find out the mass of washing soda crystal. Now how many molecules of water is present over here? 10 into H2O. H2O is 80. You have found out. So 180 water is present over here. I am not using any unit right now. So 180, this you can find out. Now you find out the total molecular weight of Na2CO3 dot 10H2O. So do that. You will get it as 286. Now out of this 286, 180 gram is water. So 286 gram of washing soda contains 180 gram of water of crystallization. This you know water of crystallization. So 100 contains what? So if you don't remember water of crystallization, go back to class 8 book and find out what is water of crystallization. So you can get, this is your percentage. Very easy one. Next you go, empirical formula of a compound. So what is empirical formula? This is the simplest formula which gives the simplest ratio in whole numbers of atoms of different elements present in one molecule of the compound. Now let us understand this. Now empirical formula of hydrogen peroxide, that is H2O2. A hydrogen peroxide molecular formula is H2O2. Now take the common factor between 2 and 2. What is that? 2. So divide this 2 and this 2 by that common factor. So you will get HO. So H and O are present in a simplest ratio, that is 1:1. And the actual formula is H2O2. Now let us do some other. Glucose, C6H12O6. So find out the HCF of 6, 12 and 6. So divide this 6, 12 and 6 by that HCF. You will get it as CH2O. So the ratio between C, H and O is 1:2:1. Okay. So empirical formula can be same for 2 or more compounds, which you can find out in your exercise also. Now, if you take glucose and acetic acid, now is acetic acid you can take it like C2H4O2. Now here 6, 12, 6, the factor is 6. Here 2, 4, 2, the factor is 2. If you divide both this by their respective factors, you will get the empirical formula as CH2O. Now there is another term This part is very important. Empirical formula of a compound, percentage composition, finding out the atomic weight and atomic mass. This part is very important as a basis of chapter 5, that is stoichiometry and mole concept of class 10. So empirical formula mass is the sum of atomic masses of various elements present in the empirical formula. If you take hydrogen peroxide, its empirical formula is HO. So its empirical formula mass is 1 plus 16, that is 17. Now for this one, empirical formula mass 12 plus 2 plus 16. So 14 plus 16, that is 30. Let us do some problem. Like in exercise, you can do directly question 12. In exercise 1C, whatever other problems are there, you can do yourself. I don't think there will be much problem. If you face any problem, get back to me. Now calculate the relative molecular mass of this ammonium dichromate. This is called ammonium dichromate. These all are required in the next class. So relative molecular mass. How many nitrogen? 2. 2 into 14. How many hydrogen? 8. How many chromium? This. 52 into 2. Chromium atomic weight is 52. Oxygen 7 into 16. So it is coming as 252 mg. Come to this. This I have done purposely because you may again make the mistake. CuSO4.5H2O. So I guess now you can understand. Now go to 13D. If you go to 13D, you will find it is written as, give the empirical formula of CH3. I have chosen CH3COOH because most mistakes are done for this. CH3COOH, you can write this like C2H4O2. So take the HCF is 2. Divide 242 by 2. So the empirical formula is CH2O. Then 14. Find the percentage mass of water in Epsom salt. Epsom salt is MgSO4.7H2. So find out the way I have shown in 12C. This one I have shown here. So you have to add this water. You know this. So it is coming at water present is here 126. So you have to find out how much 100 gram contains. So you find out the percentage of water. Then here 17. 17 it is written, urea is a very important nitrogen fertilizer. Formula is CON2H4. Calculate the percentage of carbon in the urea. Now urea molecular weight you have already found in the example problem. That is coming as 60. So 60 grams of urea contains N2, 2 nitrogen is there. So 28 gram of nitrogen. So 100 gram contains how much? Thank you so much.